Yes, we are live now.
All right. So, good evening, everyone. My name is Neeldhara, and I'm a faculty member with the Computer Science and Engineering Department at IIT Gandhinagar in Gujarat. And I'm speaking on behalf of myself and also Professor Sudarshan, who is the instructor for the Discrete Mathematics course. He's the one whose videos you have been watching over the last several weeks. And thank you very much for taking the time out to be here with us for this live session. I'm looking forward very much to interacting with you all. And I should confess that discrete math is one of my favorite topics. It's one of my favorite courses to be involved in. So I'm looking forward to chatting with you about discrete math. So I know that we have had some questions that have come in before through a form. So I don't know if you want to take those first or if you want to take those that are coming in on the live chat first. Any way that we want to do this is fine. So if somebody is here right now and they want to start a conversation, ask a question, then maybe we can take it from there. And then I can also address a couple of the questions that have come in that have come in through a form from before. Yeah. So I'm just going to see if I can monitor the live stream from my phone. So just give me a second to pull it up. Okay, I see Paranjani, Krish, and Jahanavi. I hope I pronounced your names correctly. Very warm welcome to all of you. Good evening. So yeah, please feel free to post your questions in the chat, and I will be happy to take them on. Yeah. Okay. So Abhishek Gupta, so welcome and good evening. Your first question here is where to use the pigeonhole principle. It's a great question. So it turns out that the pigeonhole principle, it sounds like a very simple statement, right? And it's also usually made with this terminology involving pigeons and holes. So it even sounds a bit silly, but it actually turns out to be one of the most powerful statements, and it's applied in a wide variety of contexts. So it comes up in all kinds of proofs. In some sense, there is a more generic way of thinking about this, which is to call it the averaging principle, where you sort of say that, okay, if let's say you have a class and you have the average marks of the class being some number, let's say 75, then you know that there must have been somebody who scored at least 75, right? If not, then if everybody scored less than 75, then the average couldn't have been 75, right? So that's one of the that's one of the alternative I mean, that's a very common consequence that comes up all the time. So you might hear people saying averaging principle sometimes instead of pigeonhole principle, and it's sort of the same thing. So it's useful. You might have seen examples also in the course where you get some pretty non-trivial geometric consequences. So for instance, when you say that you have, let's say, a large number of points in some space and you want to argue that some of them must be close enough, then that's where pigeonholing comes in. You want to be clever about drawing up the right boxes so that you can make certain implications. But certainly it comes up a lot in geometry. It comes up even in linear algebraic applications. So even some very basic statements like you cannot fit more than n vectors in an n-dimensional space and things like that go back to ideas that come from pigeonhole principle. Most commonly, I would say it does come up in combinatorics, where you're trying to prove, facts about discrete systems or sets, systems consisting of families of sets, or you have, as I was saying before, you have geometric objects, or you have graphs. It comes up a lot in graph theory. So these are some of the places where you can expect to see the pigeonhole principle come up over and over again. So it's a very, very common technique, very heavily applied. Uh, Usually, as I said, in proofs of statements of a combinatorial nature. Yeah. Prakash Kaushal, hi and good evening. Okay, Fibonacci rabbit example is more silly. Pigeons and holes are okay. All right, interesting. Yeah, well, I mean, I think one of the reasons we like working with silly stories around fairly profound things is because uh, they just make a mnemonic impact, visual, like, the sillier the example, the more visually it sort of registers in your system, I guess. I'm not going to forget about Fibonacci rabbits anytime soon, I guess. But yeah, Fibonacci is something that also shows up everywhere. I think there are also a lot of claims and nice documentaries that show how it comes up even naturally, like literally in nature. I don't know how much of that is mathematically rigorous, but it's definitely interesting to see Fibonacci and golden ratio play out in a lot of places. So yeah. All right. So Abhishek, if you want more concrete examples, I would recommend reading, reading some books. There is one called External Combinatorics with Applications to Computer Science. So it has a very nice chapter on pigeonhole principle and related techniques, and you'll find a whole bunch of examples there. And yeah, I mean, I hope that answers the question. Okay, hi Pavitra. Your question is how to prepare for the final exam on the 24th. Any tips other than going through the videos and assignments? That's actually, the videos and the assignments are a great place to start. That's a lot of the relevant content is just right there. Other than that, I think if you can practice, so I think if you can practice some more questions from the exercises in the references that have been listed, I think that will be helpful. So in subjects like discrete math, the more you practice, the more you get a hang of things. And even in the videos, I think some of the videos are marked as optional material or extra material, or they're videos which sort of just go over solutions to specific problems. I think those are useful to go over and revise once again. But just essentially be sure that you know your definitions and you know your techniques. And I think as long as you have practice applying them, that should, generally speaking, suffice. So it's not, you will need to be reasonably comfortable applying these techniques to specific problems. So practice really helps. So just knowing the definitions will only take you so far. So I think the question paper is usually, just like the assignments, it's usually a mix of both knowledge-based questions, but also actual numerical exercises that you have to solve, right? So just have to keep that in mind. Just make sure to get a lot of practice. That'll help. Yeah. Okay. Just waiting for any other questions that you might have. Okay, so while we wait for maybe other questions to come up in the chat, let me just go through the questions that have come through the form. It's maybe a good time to do it while we are waiting. Okay, is the exam descriptive or objective? Actually, I'm not 100% sure if I can answer that, but I believe the questions are going to be modeled along the assignments, and I believe they would be they would be multiple choice. But please do get this confirmed in the discussion forum with the TAs once, because it could be different from cycle to cycle. And yeah, it'll be good to get that double checked once. But my understanding is that it's modeled after the format of the assignments. Okay, it's taking me time to grasp the concepts of this course properly. Can we suggest ways of enhancing the learning process? Okay, so yeah, I would say give it the time that it really needs, because the concepts are not necessarily always very easy. Sometimes they sound deceptively simple, but you might have to, you might really have to work through it quite a bit before it becomes a part of you, becomes second nature. It's like learning any skill. It's going to take time to sort of internalize the main ideas. Sometimes you might want to find supplementary material on your own that reinforces the ideas that have been mentioned in the videos. So if you have time, so there are some really excellent YouTube channels out there that provide, for instance, visual proofs. So in particular, there is a channel called Think Twice, which provides a lot of interesting visually animated proofs. These are not necessarily rigorous mathematical proofs, but they definitely help you get some intuition for what is going on. For simple formulas like the sum of the first 10 numbers or the sum of the first 10 squares and things like that. And sometimes to do with, there's a lot of stuff there that's also beyond the scope of this course, but you might find it interesting. So depending on what sort of a learner you are, depending on if you like examples or if you like visuals or if you like, so depending on your style, you might have to go out there a little bit and look for material that suits your way of thinking. Definitely see if you can find a study partner working with somebody, challenging each other with new problems and just keeping yourself on your toes a little bit, I think is a very useful way to learn things. So make use of the discussion forum that NPTEL already has provided for you. And other than that, also see if you can find a friend with whom you're taking the course and just see if you can work through things together. You need to find the right balance of like brooding about things on your own. And, it's important to do that quite a bit. In the exams, for instance, you're going to be on your own. So you definitely want to have, and working through problems on your own is what is going to give you confidence. So you want to do enough of that. But sometimes on something that's really challenging or you just having bad luck with a specific problem, it may just save you a lot of time to get some help or to just discuss with somebody, having somebody with whom you can exchange ideas. I think that can be really helpful. So, so yeah, I hope that helps. I mean, but if you have anything specific that you're stuck with, please ask in the forums or reach out to us, the instructors, and we'll try to get back to you. Okay, there are a few questions related to logistics, so I'm afraid that that's going to be beyond the scope of this question and answer session. So for instance, about the schedule of the exams and, will the, will the exam happen or not, things like that. I think that's something that we will really not be able to address here. So you could directly write to NPTEL or you could discuss it in the forums where somebody who has official authority on these issues will be able to respond to you. I think I have already addressed the question of how to prepare for the exams because it came up in the chat. So there's one last question, which is, I think, a technical one. When you consider 10 people, you will always be able to find 4 people in increasing or decreasing order. Okay, so I have to confess that I'm not sure I completely understand what it means to find. Okay, so I assume that maybe you have some attribute associated with every person. which could be, for example, their heights. So let's interpret this question in the context of maybe people having heights, or maybe their age or whatever. It's some number that you associate with every person. And then the point is that if you have 10 people, you will be always, let's say you have lined up 10 people in no particular order, right? So not an increasing or decreasing order of their heights, but you've lined up 10 people randomly. And the point is that you will always be able to find at least 4 of them that are in either increasing order or in decreasing order. Okay, and these don't have to be 4 contiguous, I'm guessing, because I think you can show that you may not be able to find 4 contiguous, like people who are standing continuously in increasing or decreasing order of heights, because maybe they're standing in alternating order of heights. So the height might go up and then down and go up and down again. So they'll never be able to find a contiguous sequence where you see increasing or decreasing behavior. But I suppose you mean that you can find sort of a subsequence. And this actually goes back to ideas to do with pigeonholing again. So there is something called the so I believe what you want is something called the Erdős-Zechari's theorem, which might be able to help you with this. But really just think about what would happen if you cannot find either an increasing or a decreasing subsequence. You should be able to derive some sort of a contradiction. Would not say that this is completely obvious, but and I'm not sure if you're attending the live session. If you were, then we could sort of try to go back and forth on this. But in the interest of time, I'll just say that maybe if you look up the statement of Erdős-Zechari's theorem, you should be able to apply it here. So I hope that helps. Okay. Okay, I'll take questions in reverse order now. Ashutosh Pandey asks, is this course lecture helpful for GATE exam preparation? So I have to confess that I don't exactly remember the GATE syllabus, but I think that, yes, these lectures should be very relevant for GATE preparation. I do remember speak like a long time ago, so I don't know what is the latest, but discrete math is a very, very fundamental topic. So, you know, it should be something that that would help you with your GATE preparation. Prakash says that assignment 9 marks are not updated yet. So I'm sorry to hear that. I think we will pass this on to the TAs, and they should be able to follow up on it. So okay. So I just need one moment here and I'll be with you. Sorry, I just need a second. Okay, there seems to be one more question about generating functions. We want a closed form expression for the sequence a(n) equals 2n plus 3. Okay, so so we could work through this one. Maybe I will see if I can share my screen and work through it with you, but let's see. I'm just trying to see if there are any other questions that are either in the form or that have come up. Okay, Sai Krishna is asking if chromatic number can be 0 for a bipartite graph with no edges. So the chromatic number is defined as the smallest number of colors that you need to properly color a graph. Now, if your graph has no edges whatsoever, then, well, okay, of course it is a bipartite graph, but it's also like an empty graph. but you would still need at least one color. So no matter what the graph is, and even if it has no edges at all, you would still need at least one color to color the vertices, to color all the vertices, right? So the chromatic number is always typically considered to be at least one. And on the other end of the spectrum, if you have a graph which has all the possible edges, then you cannot do, and this is, I guess, again, okay, I'm sorry about that. I don't know when exactly I lost my internet connection. I am now working through a phone hotspot. Hopefully this will work. Can you okay, so have okay, maybe I'll keep my
Yeah, you
video.
can mute the video off and you can speak. I think now it is fine.
Yeah, I've turned my video off to conserve bandwidth, so hopefully this is okay. Yeah, all right. Okay, so I will just try to complete what I was saying earlier in the context of chromatic number. I was saying that the chromatic number typically ranges from 1 to n. One, because every vertex needs to get at least one color. Every possible edge is present in your graph. It's still a simple graph, but it's a complete graph. So every pair of vertices have an edge between them. In such a situation, if you were to try to color the graph with fewer than n colors, then there, as a result of which you would have an edge that violates the chromatic number condition. So it would no longer be a valid coloring. So you definitely need n distinct colors to color a complete graph, and you need only one color to color an empty graph. And those are the two extremes of the chromatic number spectrum. But yeah, just to answer your specific question, it's not going to be zero. Okay, good point. So it depends. Possible to partition the vertex set in the graph has at most an point in the other part. So if a bipartite, so the only bipartite graphs that have chromatic number 1 are the empty graphs. So the question is, would you count them as bipartite or not? And when we say, so let's say that the chromatic number of non-empty bipartite graphs is 2, and every non-empty, non-trivial bipartite graph, which has at least one edge, has chromatic number 2. You need at least two colors. Once the moment you have an edge, you need at least two colors, because that edge itself will demand two colors. And by definition of bipartiteness, you will always manage with two colors, right? And the only exception is when you have an empty graph. So the chromatic number of an empty graph is 1. So depending on how you define so okay, the or not. So so technically speaking, depending on okay. Okay, so yeah, I have just sent a message to that can be restored, but in the meantime, I can try to post a link, the answers in writing, so you can refer to that. Okay, all right. So yeah, so just to complete the conversation we were having with Sai Krishna, the only question is an empty graph considered bipartite or not? And technically speaking, if you say bipartite graphs are graphs that don't have odd cycles, or whose whose vertices can be divided into two disjoint independent sets, all of these things are possible with the empty graph. But in that case, you want to say that the chromatic number of bipartite graphs is at most 2. If you want to say that the chromatic number of bipartite graphs is exactly 2, then the definition consistent with that is that a bipartite graph is a graph without odd cycles, or is a graph whose vertex set can be partitioned into two independent sets, and it's a non-trivial graph. It's non-empty. It has at least one edge. So depending on, so either you define it as a non-trivial graph and say that the chromatic number is exactly 2, or you define it as, any graph without odd cycles, or any graph whose vertices can be partitioned into two independent sets. And then the correct statement about chromatic number is that it's at most 2. So as long as your statement is consistent with your definition, I think you will be fine. Okay. All right. Okay, Prakash and Ashutosh, again, unfortunately, that's a logistics question that I don't immediately have an answer to, but I will definitely pass this on to the team. I don't know if it's possible for you to share with us the exact lectures for which the transcripts are missing. If you can do that over in the discussion forum, I think that might help. But I'm sure that the team is working on it, and I agree that transcripts and captions really help. So I hope that they will be made available really soon. Yeah. Yeah, I would love to take on the generating functions question. It's sort of a straightforward calculation, and it might even be a textbook calculation. So, but without sharing my screen, and I'm nervous about sharing my screen with something that I can definitely link you to an explanation of. It's a pretty good exercise to work through that. Okay. Okay, Krishna, if we have this question in your exam, I don't know what was considered the definition of of chromatic number. Sorry, I don't know what. Yeah, I don't know what was considered to be the definition of bipartite graphs, whether they were defined as non-empty graphs or not. So let me just double check that and get back to you. That should be a straightforward thing for me to check. So. Okay, so Prakash, okay, so are you saying that last week's transcripts are not available? I will then pass that on. Aniket, the Catalan number problem, which was discussed in week 1, had a solution which involved thinking in a very different way. Please guide us on how to approach such a question. Okay, yes, so Catalan numbers definitely are they're interesting and a bit tricky in the sense that there are so many things where you wouldn't expect Catalan numbers to show up, and they do. They count so many different objects that look very, very different from each other. So it's hard to sort of, it doesn't fit into like, it's hard to look at a question and be able to immediately judge if it's going to, admit a solution when viewed in the style of Catalan numbers. But I would. Oh, okay. So Prakash is saying that if my network is lagging, then you can explain that Catalan question. So I'm not sure if. So Aniket, did you want an explanation with respect to a specific problem? Then again, it'll be very helpful if you can let me know which problem from week 1 you're talking about. But other than that, the general point that I was going to make is that whether it is Catalan or Fibonacci or whatever, these are sort of tools that you add to your toolkit, right? So typically what happens, and this is not just for the discrete math course, it will also happen when you do other courses, like kind of just build your exposure to more and more something that that is out there, that exists as a way to solve a problem. And then typically when you encounter a new problem, you start to say, okay, does this admit a nice recursive solution? Is it amenable to induction? Can I break it down? Is there some parameter along which I can break it down further? And so on and so forth. So once you start thinking along those lines and you have experience with a toolkit of things that you can use, then after you try a couple of things, you will sort of start to see if it has a pattern that looks like a Catalan pattern, or it looks like a Fibonacci pattern, or it looks like some generic induction thing. But my general advice is going to be that the more practice you have with such problems, the more it's going to help. There is a very nice video on YouTube called 10 Tips for Solving Problems by somebody called Grant Sanderson. And I think it's a very useful way of systematically approaching problems. And if you want a longer introduction to problem solving in general, there are a couple of books whose titles are along the lines of Art of Problem Solving and The Art of Problem Solving Using a Computer. And these are both very nice introductions to just systems of thinking that allow you to approach and solve problems. They are typically designed for people who are preparing for exams like or competitions like the Olympiad or the Putnam. These are famous competitions which usually involve a lot of questions from combinatorics and discrete mathematics, other than other fields of So these books really go through approaches, techniques, they break it down very, very nicely. But Grant's video is a great place to start. Okay, reaching 5 from the origin without crossing the diagonal, right? So so this is, I guess, so lattice paths. So the simpler question is if you didn't have the diagonal restriction, right? If you didn't have the diagonal restriction, then what would you do? Then that's just a matter of saying, oh, I can really think of every lattice path. So you get to either move right or you get to move north. You know that if I want to get from the origin to the other point, which is the top right corner, I must have made n right moves and n up moves. Right? That's the only way that's the only sort of a valid path. And now it's just a matter of choosing which ones should be up and which ones should be right. So you have a string of length n from which you have to choose which 5 go the other direction. So if you didn't have to worry about the diagonal constraint, then this would just be 10 choose 5, right? And that's the first principle, is to see if you can solve a simpler variation of a problem that you're working on. It'll give you a little bit of a confidence boost, and that's a good place to start. But after that, okay, so, and this is something that you must have seen also while working on probability problems. Sometimes it's easier to, instead of thinking about exactly the things that you want to count, you have this universe of things that you have already counted. And then maybe, you just want to subtract the bad parts, the ones that cross the diagonal. So you could think of it that way. But more generally, what's happening with, yeah, so generally what's happening here is that you want to get familiar with this idea of the method of bijection, which is to see if you can really think of mapping one problem to a problem that you already understand or a problem that you've already solved, right? So even without the diagonal constraint, we kind of mapped the issue of traversing a grid in a certain fashion to bit strings where the number of zeros and ones are equal, for instance, because you could think of every 0 as a right move and every 1 as an up move. Right, so that's, in some sense, you're drawing a bijection between every bit string of length n with n by 2 ones with lattice paths that go from the bottom left corner to the top right corner. So every string gives you a path, every path gives you a string. It's a bijection, so counting one will help you count the other. And Catalan is just taking it to the next level, where you try to map the objects that you're interested in to something that you already know that are counted by the Catalan numbers, and then you are in business, right? So yeah, okay. I'm just going to take this next question. And a question was asked in week 1, asking how many ways can we have a series of -1s and +1s such that their sum is 0. So Aniket, again, that should sound like a similar thing to what we have just discussed, right? The only way that in a string, so let's say that the length of the string is going to have n numbers, and they're going to be -1s and +1s. Then if they're going to add up to 0, what can we say about the number of -1s versus the number of +1s? Is there a relationship between them? In the YouTube live chat, I don't think I get to post Grant Sanderson problem solving, and it'll take you to this video called Tips to be a Better Problem Solver. So I was trying to link you to that video. So if if you're interested in just generally methods for becoming a better problem solver, I think that's a nice video to start. Right. Okay, so Aniket, now you're talking about a slightly different question, right? So you're talking about how can you arrange 5 1s and 5 -1s so that all the 10 partial sums are non-negative. That means that no matter where you are in your string, don't have, okay, so they have to be non-negative, which means that the number of plus ones that you see should be at least the number of minus ones, right? So hopefully that makes sense to you. And so for every I numbers, the number of plus ones that you have is at least the number of minus ones. If the number of minus ones overtakes the number of plus ones, right? Now, if you think of this in terms of lattice paths, let's say you go up and every time you do a minus one, you go right. What does that mean? That means that every string that has this property that you have mentioned, right, which is that all the 10 partial sums are non-negative, it means that, so suppose you translated this string into instructions for taking a walk in this lattice, right? I don't know if you wanted to or if you thought of making that connection, but I'm just saying let's make that connection because that goes to what I was saying earlier about the fact that you want to link this to the method of I've already seen. So we have seen the grid problem. Now you have a problem about strings, and I'm going to try and see if I can connect the two, right? So basically, let's say that we translate the string into instructions for traveling in the grid. So let's say for every plus one I go up and for every minus one I go right. Then what does it mean? It means that at every step of my walk, I have had more up moves or exactly the same number of up moves as I've had right moves. So either more up than right or the same number of up and right moves. So what does that mean with respect to the diagonal? So imagine this walk that you have taken based on such a valid string. Can you ever come below the diagonal? What does it mean that you are below the diagonal on your walk? In up and right moves. So I'll wait for you. Answer that, and then we can go forward. That means you are at a point below the diagonal. Sum. Non-negative. Okay, so I'm sorry if my voice is not clear because I'm again getting a message from Okay, I'm really sorry about the internet issues, but hopefully this will stay stable from here on out. Can you hear me in the Zoom?
Yes, ma'am, you're audible.
Okay, thank you so much. Okay, I don't know where the YouTube chat is. Just 1 second. Okay, I'm just going to refresh the YouTube page on my end because okay, sorry, the live chat is still loading for me, so I'm just waiting. Um, okay, all right. So okay, so Aniket, I don't know how much you were able to hear, but hopefully you can see the connection that for every string that has exactly 5 ones and 5 minus ones, that has the property that the partial sums are non-negative. There is a walk from 0 to 5, 5 that does not cross the diagonal. And for every such walk, you can also recover a string which has the property that you were describing. So these two objects, the set of strings with this non-negative partial sums and the set of walks from 0, 0 to 5, 5 with up and right movements that don't cross the diagonal. These two collections of objects are in one-to-one correspondence with each other. For every object here, you can find an object there, and conversely. It's a bijection between them. What we have just argued is a bijection. And since you already know how to count non-diagonal crossing lattice walks from the bottom left to the top right corner of a grid, the same count will apply to these strings. Okay, that's a perfectly valid argument for coming up with the count instead of trying to count them directly, which may be complicated. So I hope that answers your question. Sorry, it was sorry if you could not hear it properly, but I hope that helps. Okay. All right. So Sai Krishna and Prakash, you are asking about the exam question pattern. To be very honest, I actually don't know the pattern this time, but my understanding is that it will be in the same format and roughly the same level of difficulty as the weekly assignments. And I believe that the questions are multiple choice, but once again, please get this confirmed in the discussion forums once. So yeah, I think that's the questions definitely cover all the topics across all the weeks. Yeah. And yeah, and I think okay, I will try to be a bit louder. Okay. So yeah, I have a confirmation that all the questions will be multiple choice. And I think I also know that questions will be asked from across all the topics. So so please prepare across all the weeks. Although if you have limited time and you want to pick and choose, that would be entirely up to you. That would be your strategy. But I don't think I don't think there are any topics from which there are more questions and any topics from which there are fewer questions. Roughly speaking, it's a sort of an equal distribution of questions across topics. So please prepare everything as much as you can. Gyanath, in terms of suggestions for the exam, right in the beginning, what I was saying is that the videos and the assignments are a great place to start, but try to make sure that you go beyond just acquiring knowledge from the videos. So of course, knowing the definitions, knowing the terminology is very important because that's the language in which you discuss, or that's the language that you need to think about problems. But having a lot of experience solving problems is also equally important because the questions will be pretty hands-on. They will not all be definition based or recall based. The questions will ask you to solve problems just like your assignment questions, right? So do try to solve problems. What I was saying before in this call also is see if you can get a study partner and solve problems together, but ensure that you have a balance between solving problems on your own and also discussing problems with others, right? It's important to solve problems on your own to gain confidence and to sort of just go through that experience, right? The more problems you solve on your own, the more confident you will feel when you're writing the exam, which you have to do on your own. But if you're getting completely stuck on something, you can save yourself a lot of time by just asking for help. So use the NPTEL discussion forums, reach out to the TAs, reach out to ask the instructors, or try to reach out to friends with whom you are doing this course. Okay, I think that would really help, but make sure you do a bit of both. So I hope that helps. So Aniket, you say that you got the connection. I'm happy that I'm happy that that worked out. In general, just the method of bijection, it's a beautiful it's a beautiful technique because once you know how to count one set of objects, you can try to leverage that knowledge by trying to count a completely different set of objects by just appropriately mapping them. So just like the pigeonhole principle that I think Abhishek was asking about earlier, this principle of bijective mappings, it just comes up everywhere. And, it's a really clever and a very nice way of trying to, of trying to solve a problem by kind of reducing it to something that you already know instead of trying to attack it directly. So I think that's a very helpful technique to keep in mind. Yeah. Okay, so can we, yeah. Let me know if there are any further questions. The one question that I'm not able to address is the one about the it's the one about the generating functions closed form, because that's like a few lines of calculation, but as I said, it should actually maybe even be a worked out example in Kenneth Rosen or something. So please look up generating functions in Rosen because he has worked out examples for many similar sequences. So you'll probably find your answer there. But if not, I'm happy to sort of work it out for you. Take it to the forums and work it out there. अच्छा ठीक है, सारा वीकली असाइनमेंट फिर से बना देता हूँ, आंसर भी याद कर लूंगा प्रकाश. that should definitely be helpful, but I hope that you don't really need to remember the answers. It's good to have a feel. Okay, so just try to develop a sense for for what's going on, so that you can sanity check your approaches to the questions in the exam. You should have a sense of order of magnitude. So for instance, let's say the difference between n squared and 2 to the n, if you're working through numerical problems and let's say you're trying to work through something and you know that the answer should be something like n choose 2, so n squared, but your answer looks like a huge number relative to n, then you might know that something is wrong, right? So things like that, basically try to develop sort of a feel for what's for numbers, for what's going on. I don't think you have to obsessively remember answers by rote. Of course, if that's your style, and that's what you're most comfortable doing, if that gives you confidence, then by all means, but you will definitely be enriched by so I mean, if you want to do that on top of understanding things just as a second layer of security, that's okay, but that shouldn't be the only thing. Ideally, you definitely want to come from a place of understanding the concepts, right? Rather than just knowing solutions by rote, because that will not generalize. It's not scalable. So you have a different problem with different numbers. What you learned by rote will not help you, but knowing the method will help you much more. Okay. So, so when we say that the exams are similar to the assignments, you may not have the exact same questions. You may have similar questions whose solutions are based on a similar method, but the numbers would be different and so on. Okay, so please watch out for that aspect. But other than that, I think it should be fine. So, okay. So Prakash, which of the following represents the generating function for the number of ways to select 10 candy bars from a large supply of different kinds? Okay, so you are suggesting that both options are fine, is it? Can you tell me why you think both options are fine? Okay. So the point is that because there are, um, hmm, so you chose B and you got wrong because A and B was the more accurate answer. So, okay. So let me just clarify one thing. This large supply of candies is not correlated with the series inside the brackets, right? The thing that you are taking to the power of 6, that being an infinite series is not modeling the fact that you have a large number of candies. The reason why A is also a reasonable choice is because once you go beyond powers of 10, right? It's right, exactly. So you're saying because the maximum number of candies is to be selected itself is 10, right? So then the point is that beyond powers of 10, you're going to look at, so what are you going to do, right? You're going to look at the coefficient of x raised to 10, correct, in the expansion. Now, when you are generating, when you're trying to figure out in how many ways can you get x raised to 10, will x raised to 11 ever play a role? Because once you have x raised to 11, when you have picked that term from one of these, so you have 6 terms that you're multiplying, right? So in option number B, once you pick x raised to 11, that's not going to really contribute to the term whose coefficient you are interested in. So the point is that because x raised to 11 and higher terms will never contribute to the term whose coefficient you're interested in, you might as well truncate the series at x raised to 10, right? And you will get the same answer. It will not affect your answer. That is why both of them are equally valid. So this issue of large supply of candies is to say that, if you say that all the 6 candies will be of one particular type, right? Sorry, all the 10 candies will be of one particular type. That is also allowed. It's not that in one type you have only 3 candies available, so you're not. So there are no restrictions of that kind. That is what they're trying to clarify by saying that there is a large supply of all possible candies. So, you're not constrained in any way. That is why so that's why you want to kind of be careful about noticing that the answers that you get from A and B are both exactly the same. So Prakash, is that clear? Are you convinced that um, Are you convinced that both the options are equally correct? Okay, meanwhile, okay, I just noticed that there's one more question from Sai Krishna. And how many ways can you pick 4 letters from attack considering all possible combinations? Okay, so okay, all right. So Sai Krishna, I'll come back to you in a minute. Prakash, what I was trying to explain is that there isn't a concept of B being more accurate than A because they both give you the exact same answer, right? And in B, it is just that you have an infinite number of terms in the expression that you are raising to the power of 6. But notice that, the terms after x raised to 10 don't matter. And I think what you were saying is that there is a large supply of candy, so the infinite expression is more appropriate. But the large number of candy have nothing to do with the number of terms in this expression. The large number of candy is just to assure you that no matter which combination you pick, you say that, oh, 5 of my candies are going to be of one type and 5 of my candies have to be of the other type. Then for every type, 5 candies will be available. You don't have to worry about any constraints on the number of candies of a particular kind. That was the point of the question. So the infinite length of the series within that expression, that is not really capturing the idea of infinite candy. And because both of these terms lead you to the exact same answer, there is basically, the point is that you can neglect everything after x to the 11 and it's going to be the same answer. So is it clear why both of these are equally valid options? So this notion of a more accurate generating function is a bit, it isn't really more accurate because they both lead you to the exact same point. I hope that makes sense, right? Okay. Sai Krishna, suppose the word attack it was not the word attack. In attack, you have 2 copies of the letter A and 2 copies of the letter T. So let's try, maybe a simpler 6-letter word. So let me see if I can think of a 6-letter word where uh, there are no repeating letters. Okay, let's think of this word, which is acting. I think there are no repeating words there, so no repeating letters there. So if you had to pick 4 letters from the word acting, then how would you do it? Can you maybe answer that? That's again, I'm using this technique of just working through a simpler question. So, okay, Prakash, thanks for confirming. So I'm going to go back to Sai Krishna. Can you select 4 letters from acting in all possible ways? What would the answer be? Yes, Sai Krishna, we will come to attack. I just want you to answer for me what happens. Sure, but let me. I just want to work our way up to that problem. So I just want to confirm if we are on the same page with respect to the simpler word acting. Then we will come back to attack. Okay, Sai Krishna, just to understand, can you answer the question that I was asking you for the word acting? In how many ways um, can you pick four letters, considering all combinations again? Okay, so I don't want to, I don't want to just give you a number as an answer and just leave it at that to clarify the clash. I think we'll have to discuss whatever clash or confusion you're having separately. But I would say that, okay, so, all right, excellent, 6C4, right? And the reason all of those combinations are valid is because all of the letters are distinct, right? And so you would not have a problem, you would not have a problem with two things being the same, right? Because so for attack, the issue is that suppose I picked, for example, the last four letters, so that would be TACK, or I picked the first two letters and the last two letters, that would again be ATCK, right? So those would be two four-sized subsets, which would be considered as distinct sets when you're doing 6 choose 4, but they would end up being really the same subset of letters. So you want to prevent this kind of overcounting from happening. So there are a few different ways that you can try to handle this. I think one of the nicer ways is to just pretend that the two A's and the two T's are the same, right? So maybe we work with a smaller word. So first of all, notice that because you are only looking at picking letters, the order of the letters in the word is not important. So let's say that we just work with a smaller space of letters. So we identify the two T's and the two A's, and um, or okay, in other words, I would say, in fact, rather than identifying them, label them as different, and then we want to really just divide to account for the overcounting. This is what we want to do, right? So let me just see if um, I don't know if I want to work this out now. I will almost certainly make a mistake. But okay, let me just give me a minute to think about what's the best way to. Uh, I mean, you are going to get a few cases, right? Depending on how many letters are there and how many so and how many repetitions are there. So what I was saying about identifying the letters will only apply when so okay, the cases will sort of be as follows. I mean, so the four letters that you have chosen, if the four letters are all distinct, then in fact there are only four distinct letters. So that's going to be just that's going to be TACK. There's nothing else that you can do. Now these letters may have one repetition, and that repetition, if so in some sense two letters are the same, so that can either be a T or a A. So depending on whether it is a T or a A, you are going to pick both of the T's, and then from the remaining three letters you have to choose two. So that will be 2 times 3 choose 2. You could have two repetitions, in which case um, you're looking at both the A's and the T's being repeated. So are there any other cases that I'm missing here? seems to be similar to what I was saying in the sense that with both letters, with two instances of repetitions, it will be AATT. With all the letters being distinct, it's going to be ATCK. And other than that, you're going to have 6 other possibilities. Yeah, I think those seem to be all the cases. Correct. So, okay, now so are you saying that your combinations, your options are not consistent with this? Right. Right, this I agree. I can sort of follow up, but my understanding is that, I mean, unless the ordering is important, I'm not sure. Yeah, so as I said, your list of possibilities seems to be consistent with what I was saying, which is that either no letters are repeated in the 4 that you choose, or there is one letter that is repeated. So the repeated letter can be either T or A. And if it is T, then you have to choose 2 T's. And then from the remaining 3 letters, you have to make a choice of 2. So that is 3 choose 2. But the repeated letter can also be A. So it's 3 choose 2 times 2, which is, it's that 6 choices. And the number of repeating letters can also be 2. So if there are 2 repeated letters, then those have to be A and T. We don't have a choice. So right. So I think this should be 1 plus 1 plus 6, which seems to be 8. It's possible that there is some concept of let's see. I mean, yeah, maybe the question requires you to also consider orderings. I'm not sure about that. But if it is just about picking letters, then I think what you're saying is right. So I will get this double checked. Was this an assignment problem? Can you tell me in which assignment you had this? Yeah, I agree. The question should be, well, combinations versus permutations. Yeah, I'm not sure if okay, question number 2 in week 12. Thanks for letting me know. What I'll do is I'll follow up because it's also possible that I might be missing something in terms of interpreting the question. But with your interpretation of the question, your logic also seems correct to me. So I will say that for now. But I'll also double check. I think, yeah, even if there was a more systematic way of doing this, I expect that you should arrive at the same answer. Because I mean, unless you talk about orderings, even the total number of subsets of letters where everything is distinct is not going to be more than 64. So all of these numbers are bigger than 64. So I think we are probably either the question needs to be phrased differently or we're missing something. So I will. So thanks for bringing this to my attention. I think we'll definitely follow up on this and let you know. Yeah. But as of now, I can say that the method that you had for counting seems to be consistent with the cases that I have in mind also. So I think that seems to be okay for me. Yeah. All right. So good work on that. I realized that we are by now past an hour from when we started. So I'm of course happy to, do a follow-up session if you have more questions. If there's anybody who would like to request a follow-up session because their question did not get addressed in this one, please post a message in the discussion forum, and I'm sure the TAs can connect back with me and we can do a follow-up. But in the meantime, thanks a lot for being here and for your engagement. I really appreciated having the chance to interact with you all. And I see that a lot of you have exams on top of your mind. So all the best with that. Please stay safe as well. In terms of logistics, I'm sure our colleagues from NPTEL will be following up with you with more details about how the exams can be conducted safely. But in the meantime, please continue preparing and continue engaging with the course material. And I think with that, if there aren't any further questions, at least I'm trying to scroll back once to see if I missed anything. Hopefully not. Okay, so this sounds like probably a good place to wrap up. Once again, my apologies for the shaky internet in between, but thanks a lot for your patience and for sticking it out. Okay, so maybe, I'm not sure, but would it be okay to call it a wrap here? I'd just like to ask colleagues on Zoom.
Thank you, madam.
Yeah, it was my pleasure. Yeah, thank you. And a special thanks to everybody who joined us on YouTube. Prakash, Aniket, Jannavi, Arghya, Sai Krishna, Ashutosh, Paparanjani, and Ashutosh, Pavitra, Krish. I hope I got all of your names. Thank you very much for being here. Appreciate it. And hopefully see you next time. I mean, hopefully see you soon. Yeah. Thank you so much.
Thank you, ma'am.